Today we're going to look at an example of a one-sample z-test for a proportion. This problem came from your homework assignment and I received a lot of emails on it, so it has a couple little tricks in it that we'll go over. Our first step is to read it and decode it. So 47% of people believe that there is life on another planet in the universe. A scientist does not agree with this finding. He surveyed 110 randomly selected individuals and found 66 believe there is life on other planets. We're going to use an alpha level of 0.10. So the first thing we're going to notice is that this problem is asking us a question about a percentage or a proportion. Up to now, we've only been asked questions about an average. So this one's going to look a little bit different, and we need to keep that in mind when we're writing our hypotheses. So our null hypothesis is that we assume that that proportion is equal to 0.47. We're going to have to use a capital P here to stand for population proportion. We are not going to use a mu because that was average. The alternative is that the researcher believes that the population proportion is not equal to 0.47. He does not say if it's greater than or less than, just that it's not equal. So that means that we have a two-tailed test. If we're going to use the p-value method, then we need to find a test statistic. So let's go ahead and write that down. So our next step is to find our test statistic. To find our test statistic, we need to know what distribution we're working with. Whenever we are doing a hypothesis test about a proportion, we're always going to be working with the normal distribution. So that means that we have a z test statistic. Now it looks a little bit different than it did when we were talking about means. This time our z test statistic is p hat minus p all over the square root of p times q divided by n. So just to recall, this p hat over here is equal to our count over our sample size. So in this case, 66 over 110, that's 0.6. That is our sample proportion. So our sample proportion is 0.6. Our population parameter that we're testing it against is 0.47 over the square root. P again is at 0.47. And Q is 1 minus 0.47. And then that divided by our sample size, which is 110. So when I put that into my calculator, I got 2.7318, I believe. That means our test statistic is 2.7318. If we want to find our p-value, we're going to find the area in the tail from our test statistic to the tail. So here's our p-value. And even though I'm not an artist, it still helps me to kind of sketch a normal distribution. So here's my normal distribution. Looks maybe something like that. Okay, we'll try one more time. And 2.73 is maybe somewhere over here. So let's say that's 2.73. Our p-value is the area in the tail from this test statistic all the way to positive infinity. So I want to know this area. Well, we have a way to do that. We have a normal distribution, so we're going to use the normal CDF. The minimum, well, let's make that a little bit smaller. Move it down here. Normal CDF. The minimum value is this 2.73. 2.7318 to positive infinity, the mean of 0 and a standard deviation of 1. So that gives me, let's see, normal distribution. So again, I'm going to go second distributions, normal CDF, 2.7318. My upper limit is infinity, and then I get I'm just putting that into my calculator right now. And I hit the wrong key. Let's see, that gives me 0.003149 approximately. Now, that is for just the area in one of the tails. But we had a two-tailed hypothesis test, so we actually need to multiply this by 2. So I get 0.006299. This is our p-value for our two tails. So now we ask the question, is this p-value smaller than alpha? If so, we can reject the null hypothesis. So if we go up here, we remind ourselves that our alpha was 0.1. Well, our p-value is definitely less than 0.1. So our decision is going to be to reject our null hypothesis. Well, what does that mean? That means we have evidence to support our alternative. And our alternative hypothesis was that the proportion is not equal to 0.47. So we would write our summary. And we would start at alpha equals 0.10 level. We have enough evidence to support the claim that the proportion of people that believe in life on other planets is different than 0.47. This would be the level of work I'd expect on your midterm or your final exam. You do need to be able to calculate the test statistic by hand and be able to calculate the p-value if I just give you a test statistic. If you have questions, feel free to email me.